Welcome to this webinar part 2 to measure the unmeasurable. I will now continue to do factor analysis and cluster analysis. So I start with a demo how you do this and to understand the results. And then I will use PowerPoint for that. Here is my data file about traffic behavior. I have a lot of variables. You can also see all the labels, but if I click on this button, I can see that under these labels you have numbers, and that's the numbers that SPSS is going to work with. All the questions that you saw in part 1 is here, and you also see a label box coming up. It's important to keep the flow or traffic. I buy cars with extra engine, and so on. A lot of statements. And all these statements that you see here is the statement I would like to see how they are grouping. So I would like to use factor analysis. The command is here, analyze, dimension reduction, factor. Then I choose all the questions from the questionnaire, all the variables, and put them in to the variables box. I use the go to rotation and click Varimax. I also would like to sort it up, so I click on options and sort up the loadings, and I also suppress small coefficients like under 0.30 so I don't have to see it. Continue. I come back to the scores that you have here. So I click OK. I get the results. First I get something called communalities, and here you could find information about noisy variables. Then we have total variance explained, and then a component matrix that I always use to hide. You can hide just by double click on the little book. Then you see the rotated component matrix. That's the one I will come back to later. So let's have a look what I was doing. The options I choose from the menus were Varimax rotation, rotated solutions, and then I went to the options button and clicked on sorted by size and suppress small coefficients, and I chose to have 0.30 as a limit. Then I was hiding the component matrix, and to hide a result you just double click the icon. The component matrix is similar to the rotated matrix, but the rotated matrix has more clearly groups. So let's start with the first result. Have a look on the cumulative loadings table and look at the bottom part of the table. There is a number and it should be as high as possible. At least I wish it to be higher than 60%. Here is 55%. This number is showing me how much information I've caught through the 5 groups that I have here. You see 5 components here. Here I have 55% and I would like to have it higher. And one way to get it higher is to clean up the variables, and you clean up the variables that is mixed and belongs to more than one group. And I will show you an example of that. So let's have a look on the rotated matrix with the groupings of my questions variables. We have a look on column 1. The numbers you see in the matrix is called factor loadings, and every column is a factor, or as I call it, a group. Variables that has a high loadings means that they belongs to this group. It's similar to the correlation coefficients. If they load more than 60%, 0.60, I will say it's a high loading and a variable that is typically for this group. So let's see which variables load high to the first factor. You see the red circle, and the variables that belongs here are it's annoying to drive behind the driver who keep the limit, and it happens that I drive 30 km per hour and more. And the third one, I think it's okay to drive a little bit faster than the speed limit. So these 3 questions has loadings over 0.60 and is typically for the first group, and that means that they are correlated to each other if you should try to do a Pearson correlation, for example, and use these 3. But if you have a look on this variable, I make sure to follow the speed limit. Then you see that this question loads on 2 groups or 2 columns, column 1 and column 2. It has a negative loading on the first group, and that means that it's a negative correlation to the top three variables about like to drive fast. And then it has a small loading also to the second column. So that means that this variable is noisy or mixed up, and we should delete the variable and then run the factor analysis again without that variable. But I always take away the most noisy variable first and run the analysis and then repeat this until the cumulative loading is as high as possible and above 60%, 0.60. In the project I was included, we repeated this 10 times. So from 35 variables, we only had 25 in the last factor matrix. Next factor or group is variables that is statements about more careful or afraid in the traffic, like hard to park, worried to be hit, and so on. Maybe not so experienced drivers. We have more factors, so let's go to the next PowerPoint page. Here we have the third factor or group, and we have quite another type of questions like I follow the automobile market, I read magazines about cars. So here we have more interest of the car itself, not statements about the driving. And next group of variables are more about using collective transportation like bus instead of taking the car. And factor 5 I skipped to talk about. I just wanted to show that there is one single variable in the last factor, number 6. It's not so important which model I drive if the car is good and safe. That means that this variable or question is not correlated to any one of the other variables. That's also interesting information. The next step is to repeat the factor analysis and each time take away the most noisy variable until you have some clean factors. And in our project, we ended up to have 4 groups of factors. And when you're satisfied, you can save the index. I mentioned that before in part 1. You can calculate your own index like mean values between the variables that is positive correlated, but you have the opportunity to save factor scores also directly from this analysis. So I will show you how you do that. So I go back to the same command again, dimension reduction factor. We now pretend that I have cleaned and taken away variables that I don't want by just doing like this. And then when I'm ready, I click on scores and save as variables and then continue and OK. So if we have a look now in my window, in the right part of the data file, I have new variables and I got 6 new scores. And that's because I had 6 groups. The first one has to do with like to drive fast. So let's go back and repeat and understand the results. What I did was to go to Scores button and then click on Save as Variables. I got some scorings, and in my project example, we had 4 scores in the end after all the cleaning was done. And this scoring is calculated as a weighted index. The first column we could call active driver. So you can see scorings normally between -2 and +2. And we also have some outliers with more extreme value, like 8, for example. The reason why I took the name active driver was because here we had variables about driving fast. If you remember the red circle in the rotated matrix, we can see that person number 1 liked to drive fast, and also number 3. The minus scores is not so active drivers. The next variable we can call not experienced or afraid of driving. So we can see that person 4 has a high score, is not experienced. The third creative variable we can call car techniques. So person that has higher score is person likes to read car magazine and so on. The last created index variable we can call public traffic. And here we don't have any high score, but as an example, we can see a very negative score, a person that is not using the public communication. So these scores is a way to measure the unmeasurable, the traffic behavior. And these scores belongs of all the questions from the questionnaire, but they are weighted scores. So if we repeat the index, the goal is to catch more information than just one single question in the questionnaire to be able to measure something hard like satisfaction, feelings, attitudes, and so on. In my example, I would like to see which driver like high speed, but it's also interesting to catch information about afraid drivers. If you're interested to work with index, then I will repeat which different ways you can create these index variables. First, as I mentioned in the part 1, is to use mean values. And then you choose the most important variables, the highest loading from the factor analysis. You can take the 3 first, for example, but you must know that all must have positive correlation. And that's something that you can test with Chromebox Alpha. I have talked about this in a blog post just after the summer. The benefit to use mean index is that it's possible to compare the index in repeated similar project in the future. Next type of calculation could be sum, but remember that it's not possible if you have missing values. Then you have the factor loadings, as you saw in my demo example, the factor scores. And these scores are weighted from all variables and the weights are the same as the loadings. So high loadings has high weights. But here you have to note that it's not possible to compare between repeated projects as the factor analysis will look different with different factors and loadings in different projects. One benefit is that you can catch a lot information that has high variation, and that's good for other statistical analysis like cluster analysis, for example. If we should do a plot of the 2 first index variables I created from the factor scores, then it could look like this. We have unexperienced in the vertical axis and active drivers in the horizontal axis. So in this part of the scatter plot, we have active driver that is experienced because they have low scores on the unexperienced index. So that's an interesting group. So if I should have a name of the people who is in my circle here, I could call them active driver that is experienced. But we also have a group here that's a risk group, active driver that is unexperienced. So this is an example how you can cluster your individuals. The people who is similar to each other will create a cluster. So I will come back to that and do cluster analysis. But first, just summarize the factor analysis. What is the goal or goals? The goal is to reduce a lot of information and also to measure something unmeasurable, like my index, and that I showed in my traffic behavior project. One goal is to understand relationships between variables or questions in a questionnaire because you have correlation in the background. I decreased 30 questions to only 4 groupings in the end. I created 4 scores. I call it index, and that's a way to catch unmeasurable information because every score has several variables or questions included into the score. And then you can use factor analysis to reduce information so you can use it in regression analysis. So for example, the 4 scores could be used in regression analysis or cluster analysis. The good thing is that they are not correlated to each other, these 4 variables. So if we go back to this plot again, every dot in this scatter plot is an individual, and we can see that some of the individuals are close to each other because they have answered the question similar. So now we come to my next analysis, cluster analysis, and that's a help to find groups or individuals that are similar to each other. But I will use more than just 2 variables. I will use all 4 scores. So I first start to do a demo and then I continue to understand the result in the PowerPoint. So I go to Analyze, Classify, two-step cluster. I mark the variables I would like to use, and the thumb of rule is that these variables should not be too many and they shouldn't be correlated. I take the 4 first here and put them into the continuous variable as we have this ruler symbol. If you have categorical variables, you put it here in the box above. I also click on Output and I click on Create Cluster Membership Variable to save cluster membership and continue. And then, okay, here is my result. I can see that I got 8 clusters here. And if I double click on the result, we can see all the clusters. If I go to the bottom part here, model summary, I can see clusters like this. And if I click on one column, I can see that the right window will be a little bit different when I click on different columns. You will see that different small dots are coming up in different colors, and that's the cluster comparisons. So I will now continue to explain this. I go to the PowerPoint. So in my example from the project, we had this result. So we got 5 clusters, but I skipped cluster number 3 because it was only 18 people in that cluster. Every cluster has a different color. And the diagram you see is a box plot. We have a median score in the middle line in the box, and then in the left end of the box is the first quartile, and the right end is the third quartile. Now we can compare the 4 clusters, how they are placed in this box. And this box is the variable about inexperienced drivers. That was the first score or index variable that I had in my data file, and that was created from the factor analysis. If we start to look at the light blue color cluster, who are they and what is typical for them if we look at my 4 factor scores about the traffic behavior? We can see that the first index that we called unexperienced driver has a high scores in the light blue cluster. It means that they are the inexperienced drivers. They differ a lot from the other clusters. In the next variable about car technique, we see a low score for the light blue cluster, and that means that they have no interest of car technology. The other variable, like active drivers, is neutral. It's more in the middle. Also, the last variable about public transportation is neutral. So the common name for the light blue cluster should be unexperienced drivers with no interest of car techniques. So that's the cluster number 4. We continue with the red cluster, cluster number 2. There we could see other characteristics. The first variable, unexperienced index, shows a low value for the red cluster as they are to the left in the box plot, so they are not unexperienced. They are experienced drivers. Next, 2 index variable are both neutral, and then the last one is the one who has a little interest of public transportations. So let's call the red cluster experienced driver that is willing to use the public transportations. Let's go over to the dark blue group because it's very important to find something that is common in the cluster. We can see that the blue group is neutral in the unexperienced index. They are interested of car techniques and they have low scores on the active index, so they are not active drivers. And compared to the other clusters, they are more interested to use public transportations. So the blue cluster are people with high interest of car technique but not active drivers who is happy to use public transportations. So then the last is the green cluster, cluster 5. And if we look at the variables for these people, we can see that they are experienced driver because they have low scores on the unexperienced index. They are neutral to car technique. They are extremely active drivers. They are far above the third quartile, and they are not all interested to use the public transportations. So a name for these drivers could be speed lovers, for example. So I wonder if this could be the cluster that we was extra interested of in the project with speedy drivers. People who like to drive fast and experienced drivers. Are they interested of the equipment in the car with warning systems when you drive too fast or not? So let's have a look. If I compare these cluster groups with the bar chart, and then I also including the fifth group, the outliers group with 18 people, I can see that the last cluster, they have a blue bar that is higher than the rest. And that means that they are not interested of the speed warning systems in cars. I will also remind that this project was made many, many years ago, so the result could maybe look different today. Instead of a chart, I think a table made in custom tables could be fair to show. So if you look in the rows, you see 5 categories, and these 5 categories is from this new variable that I saved, the 5 clusters from the cluster variable. In my example here, I had more than 5 clusters, as you can see, but every driver has been placed in one cluster. So we can see here that these two people are similar to each other because they belong to cluster 1. So we have 5 clusters, and I have named all the clusters. So category 1 is interested in car technology, 2 is experienced driver, then we have outliers, and so on. So the biggest interest of speed warning system could be found in these 2 clusters that I have blue circles around. It's interested car technology and no experience and no car interest. And if we also include the probably answer, that they probably want to use this equipment, we can calculate 67% among the people in the not experienced cluster, the people who are maybe a little bit afraid in the traffic. There we have a high interest of speed warning system. Active drivers are not interested of this system, and that's something that we saw in the bar chart. So instead of using 30 variables to understand if they are interested of this equipment or not, I have only one variable with 5 cluster groups. And you could say that all the questions from the questionnaire is somewhat included in this single cluster variable. The summary of cluster analysis is to find clusters or segments of individuals who is similar to each other. When you use cluster analysis, think about that you should just use a few and not correlated variables. A smart way is to do factor analysis before to reduce the variables and create index variables that I used in the cluster analysis. You can also save the cluster groups or segments, and that's something that you can use in other analysis, like I did with the bar chart and the table. So what you have seen today in part 1 and part 2 is how to understand correlation, index and groupings, and how to explain traffic behavior with statistics. And that's a way to measure something complex. After the factor analysis, I saved some scores, and these scores or index was used in the cluster analysis. And in the cluster analysis, I got the information which drivers are similar to each other. Then I compare this cluster against interest of speed warning system. In my project, we had 5 clusters. Thank you for watching this webinar and welcome back.